Today we'll be continuing from our last class where we talked about MEOSIS and cell cycle and cell division. Today we'll be talking about meiosis. Now, of course, we know that like meiosis is also a form of cell division. But the difference that lies there is that in meiosis, the parent cell divides into 4 daughter cells. That means the parent cell gives 4 daughter cells. Now remember that in mitosis we said the number of chromosomes in the parent cells is equal to the number of chromosomes in the daughter cells, but that is not actually the case in meiosis. Now in meiosis, the number of chromosomes in each daughter cell is half the number in the parent cell. Meaning, if the number of chromosomes in the parent cell is equal to n, then the number of chromosomes in each daughter cell will be equal to n over 2. Hope you understand. So, the number of chromosomes, yes, n. The number of chromosomes in each daughter cell will be what? N over 2. Now, meiosis is a very peculiar process because it takes place in only the reproductive cells like the sperm cell or the ova, because that is where it takes place. Because during the fission of the sperm now and the ova, if the sperm which has n over 2 combines with the ova which also has n over 2, we end up getting the same number of chromosomes as the parent cell. So that is basically just what happens in meiosis. Now in meiosis as a complex process can be divided into different stages. Now, of course, it can also be divided into the prophase, the metaphase, the telophase, and the anaphase. But we'll be looking at them in different stages. Meiosis can be divided into the prophase 1, metaphase 1, anaphase 1, telophase 1. Then we now have the prophase 2, metaphase 2, anaphase 2, and the telophase 2. Now note, prophase 2, metaphase 2, anaphase 2, and telophase 2 are exactly similar to prophase, metaphase, anaphase, and telophase of meiosis. Now, the most peculiar process where the actual separation or actual division of chromosomes take place is actually from all these processes. This prophase 1, metaphase 1, anaphase 1, telophase 1. Now, we're going to be looking at all of them one after the other. We're going to be looking at all 8 processes one after the other. Now, we're going to be looking at the prophase 1. Now, I'll call this the most complex process of meiosis. Now, this prophase 1 can be subdivided into the following stages. We have the leptotenin, zygote, the diplotenin, and the diakinesis. Now, during the leptotenin stage, the chromosomes or the chromatin threads condense and become more visible. They coil up and become more visible under light microscope. Now during the zygote stage, at this stage, there is pairing of homologous pair of chromosomes. Where homologous pair of chromosomes they now become joined at their synapse, at their synapse, at their synapse, at their synapse. They become joined at their synapse. Now, during the partitioning stage, now at this stage, this is the actual stage where crossing over takes place. Meaning, this is the stage where there is mixing and there is exchange of genetic components. This is where stage where crossing over takes place. Now, during the diplotin stage, now at this stage, the chromosome becomes more condensed. They become more condensed. Now, the diakinesis stage, a difference between the diakinesis stage and the diplotin stage is that at the diakinetic stage, the chromosomes are actually more condensed than that of the diplotin stage. Then, also during the diakinetic stage, the chromosomes separate a little. They separate a little at their chiasmata. There's little separation at their chiasmata. Now, during the diplotin stage, the basic thing that occurs in the diplotin stage is the condensation of chromosomes. So these are the stages of the prophase 1. These are the stages of the prophase 1 of meiosis. Now, after the prophase 1, of course, the next stage is the metaphase 1. The next stage is the metaphase 1. The metaphase 1. Now, if you remember in mitosis, I said that during the metaphase there is alignment of the chromosomes at the middle. Now, the same thing will occur. Now, in metaphase 1, the bivalent pair of chromosomes they also align at the middle of the cell. Now, let's imagine this is our cell. Let's just try and give a diagrammatic explanation to this. Let's say this is our cell. Let's say this is our centrulose. Of course, we have our continuous fibers. Then we have our chromosomes. We have our chromosomes. Now you can see that the bivalent pair of chromosomes are actually aligned at the center. You can see that the bivalent pair, what I mean by bivalent pairs, that we have two different pair of chromosomes joined together by their chiasmata. Although each pair of chromosome is joined at their centromere. Yes. Now, this is basically what occurs in metaphase 1. There is alignment at the center. Now, at the anaphase 1 stage of mitosis, the anaphase 1 stage of meiosis. At the anaphase 1 stage of meiosis, the bivalent separates and each chromosome moves towards each pole of the cell. Now let's say we have a cell. Now, what occurs here? Now we can see that the chromosomes are actually being drawn together to produce cell. Now, if you observe, the chromosomes, they are still in pairs here. So, next stage is the telophase. One stage is the telophase. the telophase 1 stage, the telophase 1, the telophase 1, the telophase 1 stage, the telophase 1 stage. Now, during the telophase 1 stage, each of these chromosomes actually reach the pole of the cell, and then by that time, cytokinesis will also take place of the division there. But after the telophase 1 stage, there will still be a need for further division because each cell now still contains chromosomes, like homologous pair of chromosomes that still needs to be separated and divided into another set of daughter cells. So at the end of the first stage of meiosis, we have two cells. Now each of these two cells will now undergo the second stage of meiosis. Each of them will undergo the second stage of meiosis. Now the second stage of meiosis, which is the prophase 2, the metaphase 2, the anaphase 2, and then the telophase 2. Telophase 2. Now each of these stages are exactly similar to that of meiosis. And they are to mitosis. They are exactly similar to that of mitosis. Exactly similar. During the prophase 2, we actually see the condensation of the chromatin threads into chromosomes. During the metaphase 2, the chromosomes will align at the center. Then during the anaphase 2, there will be separation. Then during the telophase 2, then there will actually be cytokinesis. So each daughter cell will now divide again into another set of cells. So at the end, we now have four cells at the end of at this end of meiosis. We now have 4 cells, and each cell will contain half the number of chromosomes as to the parent cell. Okay, now let's do a quick recap of what I've been saying since. Now we said meiosis, the process of meiosis. Meiosis is the process involved where the parent cell divides into 4 daughter cells, where each daughter cell contains half the number of chromosomes to that of the parent cell. Now we also said they can be divided into different stages, where we have the first stage, we have the second stage. We also said the first stage is the prophase 1, the metaphase 1, the anaphase 1, and the telophase 1. The second stage is the prophase 2, the metaphase 2, the anaphase 2, and the telophase 2. Now if you want to know more of what I said in the second stage, you go and review the video on mitosis, because the second stage is exactly similar to that of mitosis. Now we said the prophase 1 can be divided into different stages, where we have the zygote stage, we have the diplotin stage, the zygote stage, the paclitatin stage, we have the diplotin stage, and we have the dikinesis. Now, very importantly, you must note that crossing over takes place at the paclitatin stage. Now, during the leptotin stage, the chromosome condenses, then moves to the next stage. During the next stage, the homologous pair of chromosomes, there's pairing of homologous pair of chromosomes, which now during this pairing, we now have bivalent pairs where they pair together, they join together their chiasmata. Now move to the next stage where there's crossing over, then to the next stage where the chromosomes they condense more, then to the final stage where there's actually more condensation, and then there's a little separation at the chiasmata, just very little separation. Now remember that the application of these chromosomes actually took place in the S stage of the interphase. Now also we went to the metaphase stage. Now during the metaphase stage, we said they align at the midpoint. Then to the anaphase, in the anaphase, we said during the anaphase they are dragged towards the pole. Then the telophase. Then during the telophase, we actually talked about the part that where there is cytokinesis and the division into 2 daughter cells. Now these 2 daughter cells, we also need to undergo another set of division, because they have not achieved the aim of meiosis, which is to form 4 daughter cells which have the number of chromosomes. Now the second stages are the prophase 2. Prophase 2, in which the second set, the two daughter cells, their chromosomes condense. We see the spindle fiber formation again. Then we see that the nuclear envelope will actually disappear. The cell become more viscous, non-refractile, more spheroid. Then we move over to the metaphase 2, where there is the align at the center, the chromosome align at the center, to the anaphase 2, where they are dragged towards the poles. Then we move to the telophase 2. During telophase 2, don't forget that the cells, each daughter cells now also divide into another set of two cells. Another set of what? Two cells. So at the end, we have one parent cell giving it to 4 daughter cells. Now the number of chromosomes here is n. This will be n over 2, n over 2, n over 2, n over 2. Now a very good importance of meiosis is in the reproductive process, in the formation of this the sperm cell or the ova. That's a very importance of meiosis. Where we said also mitosis, we talked about the importance as to growth. And note that mitosis occurs only in the somatic cells. Somatic cells mean non-reproductive cells. Then meiosis occurs only in the reproductive cell. Okay, now let's do a quick recap. Of the following. Now let's take the first question. Now let's see this question. Now the longest stage of the cell cycle is the what stage? Is it A, the interphase? Is it B, the telophase? Is it C, the prophase? Is it D, the anaphase? The longest stage of the cell cycle is the interphase. The prophase is the longest stage of mitosis or meiosis respectively. Okay, now let's take another one. The cell gathers energy at what stage of the cell cycle? Cells gather, or what stage of the cell cycle has the highest metabolic activity? What stage of the cell cycle has the highest metabolic activity? Is it A, the prophase? Is it B, the telophase? Is it C, the anaphase? Is it D, the metaphase? Is it E, none of the above? The cell has the highest metabolic activity at what stage of the cell cycle? Is it the prophase? Is it the telophase? Is it the anaphase? Is it the metaphase? Or is it none of the above? Okay, the answer is none of the above, because the cell has the highest metabolic activity at the interphase stage. Interphase stage. This is the stage where the cell has the highest metabolic activity. Okay, now let's take one more question. In meiosis, crossing over will take place in which of the following? Is it A, prophase 1, B, metaphase 2, C, prophase 2, D, metaphase 1. Okay, actually crossing over takes place at the Pachytene stage, we know, but don't forget that the Pachytene stage is under the prophase 1, where the prophase 1 can be divided into the diaplasine stage and the rest. So the answer to this question would fall under prophase 1. So that will be very correct. Now, if you have any question, you you can do well to ask the question under the comment section. We'll surely answer them. And also, don't forget to review the notes under MEOSIS. Very important. Thank you very much. Please don't forget to subscribe. It's also very important. Thank you for your time.